All right, IM2 classes. Today we're going to wrap up our right triangles and we're going to do some right triangle word problems. So let's get right into it. Um, so first, uh, a construction crew needs to install a support beam that will extend from the ground to a point on a building wall. The building wall is perfectly vertical, straight up and down, and they need to place the beam at a point 45 feet up the wall. Due to space constraints, the base of the beam must be placed 24 feet from the building's base. What length of support beam will the crew need to purchase to reach from the ground to the specified point on the wall? So first thing you want to do, I'm not sure if you can see it behind my picture there, but you want to sketch a diagram. And then, you're going to want to look at it and see what method to use to solve the problem. The methods that we know, Pythagorean theorem, special right triangles, and then trigonometry, SOHCAHTOA, or inverse trigonometry. Um, so for this one, we have the wall is perfectly vertical. So I'm going to sketch a wall. All right. I'm going to put, so here's my, yeah, okay, great. Here's my wall. And this needs to be, it's 45 feet. The support beam is going to come down this way. Um, and it needs to come to a spot that is no more, or that's 24 feet from the base wall, so 24. So this forms a right triangle. We need to figure out how long the beam is. Um, I'm gonna put this, I don't like having the numbers on the inside of the triangle. Um, so this side, the wall is 45 feet. The ground, the beam is going to be 24 feet from here. This is a Pythagorean theorem problem. We are trying to find x, the length of the beam. So we are going to use a squared plus b squared is equal to c squared to find this. So just like always, we're going to label the sides A, B, and C. Starting with C, C is the longest side. So C is x. And then A and B are interchangeable. Doesn't matter where you go there. So it's going to be 45 and 24. So it's 45 squared plus 24 squared is equal to x squared. And then we're going to solve this. So 45 squared is 2025 plus 24 squared is 576 is equal to x squared. So 576 plus 2025 is 2601. And then the last part, we are going to square root both sides. So second square root 2601, that comes out to 51 feet. So our beam needs to be 51 feet long. So pretty simple. Really helps to draw that diagram so you can see what information you know. Make sure you label it. Um, you know, you can label the floor and the wall, and that'll just help determine um, what things should be. So let's move on to the next one. We got to move this. Nope, nope. An architect is designing a wheelchair accessible ramp for a new office building. Building codes require that the uh, ramp's angle of elevation cannot exceed 4.18 degrees. If the entrance is 3.5 feet above the ground, what is the minimum horizontal distance the ramp must extend from the building to meet this requirement? So we're going to have a ramp. So it's like there's a little step coming up here, all right? And this is 3.5 feet, this little step. I guess I don't need that part. We're going to have a ramp coming down this way. We don't know what the ramp is, how long it is, uh, but we need to figure out this horizontal distance here. We know the angle in here. I'm going to actually sketch this out a little bit better and move it so it's not right in the middle of where I want to work. So here's a ramp. It's going to come to the top of a step. This is going to be 3.5 feet. The angle of elevation, what that means, this ramp has an angle right here. This is 4.8 degrees. All right. So when we know an angle measure and a side length, to find missing sides, we use SOHCAHTOA. We use sine, cosine, or tangent, our right triangle, trigonometry. So SOHCAHTOA. Um, the side we're trying to find so was the minimum horizontal distance. Horizontal is flat, left or right. So we're trying to find this side here. So let's start off, label our sides. So the ramp here is going to be the hypotenuse. Our eyeball in the angle, the eyeball is looking at the opposite side. And then the side left over is the adjacent. So we know the height of this opposite side, that's a no. And we were trying to find the adjacent. So O and A, which uses O and A, that is tangent. So I'm going to set up a tangent function. So it's going to be tangent of 4.8 is equal to the opposite over adjacent. So remember when our x is on the bottom, a little shortcut to solving this instead of, multiplying and dividing, what we're going to do is just take our trig function and our x and they just flip-flop sides. And that's what we do when x is on the bottom. So this is going to be tangent of 4.8 is equal, no, see, I said flip-flop sides, but then when I'm doing it, I didn't actually flip-flop when I'm rewriting it. So it's going to be x is equal to 3.5 divided by the tangent of 4.8. And let's see what that is. 3.5 divided by tangent of 4.8. That comes out to 41. Tangent of, so 3.5 divided by tangent of 4.8. Yeah, okay. So X is going to be 41.7 feet. That's going to be a long old ramp. That's it's going to end up being like a 50-foot ramp, 45-foot ramp. Oh well. Um, yeah, I guess that makes sense. 3.5 feet is actually quite high. If you think about it, that's not one step. So that does make sense. 41 feet is that horizontal distance that they need to make. And then if they want to go a step further and figure out how long the ramp needs to be, they can um, use Pythagorean theorem or trig again. But anyway, let's move on. Last one we're going to do here. A roofing contractor is measuring a house's roof line for shingle installation. The roof rises 12 feet from its edge to its peak and extends horizontally 16 feet from the edge to where it meets the peak. What angle does the roof make with the horizontal? The contractor needs this angle to determine the shingle installation or the roof runoff. So if this is so it says the roof rises 12 feet from its edge to its peak. So this is the edge and it rises 12 feet. All right, so that's 12. And it's going to come down here. It extends horizontally from the edge to where it meets the peak. So that's going to be 16 feet down here. What angle does the roof make? And that's going to be X in here. We're going to try to find that angle. So what's the angle of elevation of the roof need to be for proper runoff? Um, or to meet these distances here. So this is going to be another SOHCAHTOA problem where we know two side lengths and we're trying to find an angle. So SOHCAHTOA. All right. So my eyeball is going to go in the X. The eyeball is looking at the opposite side. The hypotenuse over here is the longest side. So the side left over is the adjacent. So when we're trying to find an angle, just identify the two side lengths that you know. I know the opposite and I know the adjacent. So opposite and adjacent, O and A, that is tangent again. So this is going to be a tangent of x, so we're trying to solve for x, is equal to the opposite 12 over the adjacent 16. So remember to solve, when you know what, when you're trying to solve for x in trig function, we use the inverse tangent. So the opposite tangent is the inverse tangent of both sides. So the tangent and inverse tangent cancel each other out there. So you have x is equal to second inverse tangent 12 divided by 16. That comes out to 36.9 rounded. So 36.9 degrees. So that roof is a rise of 36.9 degrees. So that'll do it for us. The rest of the problems are just like those. So make sure you refer to those as you're working through the other ones. Sketch a diagram and label it, and that'll help you. Um, but yeah, we will see you guys next time. Maybe.